And you're back for more. Nothing makes my heart happier. This is part 2, okay, of our Unit 5, the definite integral review unit. All right, we just finished part 1. We're on to part 2. I believe we left off with average integral. I don't know. Let's go see. Let's find out. There's no better way than to just do, right? Do. You like that part 2? Never mind. I'm sorry. Oh, and I was right. Look at that. The mean value theorem for integrals. It's the average value for area under the curve. Are you ready to learn some math? Math. There it is, okay? If I want to find the average value, I take the integral with its bounds, and then I divide that by the difference in its bounds. Or if I'm dividing something by 2, that's the same thing as multiplying something by a half, okay? So you will see it written like this, okay? 1 over b minus a times the integral of f of x from b to a. Or in some textbooks or in some teachers' classes, they take this and divide by b minus a instead of doing it like that, which is fine. Either way, I like to handle the integral separate and then multiply by 1 over b minus a. All right, so if I'm to find the average for anything, let's say you took 6 tests, okay, and you got a 100 because you're smart, and 90, I don't know, you were having an off day and you got a 78, man, that's a big dip, 89, 1, 2, 3, 4, 92, and let's end with a 97, okay? 6 tests. I add them all up. Okay, remember, the area under the curve, I'm adding up all those rectangles, right? I'm adding up all those things. But now, okay, if I have 6 tests, I got to divide by 6. Okay, in this case, if I'm going from 4 to -2, that's a difference of 6 spaces. Okay, let's make it easier. I don't know how I can make it easier. Let's go from 7 to 1. Okay, that area is being dispersed over 6 spaces from 7 to 1. So I got to divide by that. That's what gives me my average, okay? So it kind of makes sense that we are going to divide by the difference or the distance in our bounds, okay? Or instead of dividing, we multiply by 1 over that value, okay? All right, let's do some math here, shall we? Enough of the explanation. Find the average value. As soon as I see that average value of the function, I am thinking, this thing right here, okay? So find the average value of the function on the interval using antiderivatives to compute the integral of the following. Okay, let's start out simple. Y equals 3x squared on the interval from -1 to 2. Okay, this would be my a value, this would be my b value, and my integral from -1 to 2. Of what function? Of this function, 3x squared. Don't forget the dummy variable, please. If they ask you to write an integral to represent this equation, and I'm not done yet, don't say like, I thought we have to do the 1 over the b minus the, I'm not done. If they ask you to write an integral, you cannot forget that dx or it will be marked wrong. Now, this is the integral for this right here. But if they want you to find the average value, I need to multiply that times 1 over b minus a. 2 minus -1. Okay? So that's what makes it average. Okay? If I don't have this here, that's just the integration. But when I add it back, pachow, that makes it average value, average integration. All right, so let's do this math, okay? Well, 2 minus a -1, well, that's 3, so it's 1/3 times. The integration of this right here is x cubed, but I want that from 2 to -1. So I'm taking this, I'm going to do all this math, and then at the end, multiply it times 1/3. Okay, so again, let's do some math. Okay, I'm going to first start by putting a 2 into my x cubed, find that value, and subtract, putting a -1 into my x cubed. So I've got 2 cubed minus, okay, let's do this here, negative 1 cubed. Okay, don't forget, I'm going to multiply that whole thing by a third. The whole thing by a third. So 8 minus negative 1 times a third. Okay, when I subtract the negative, it's like super positive. So I've got 1/3 times 9, and that answer is 3. That's the average value. All right, pretty simplistic when it's the easier problems. But let us move forward. Let us progress our positive and intellectual thought process here. And now, oh my goodness, 1/x. Everybody start crying. It's really simple. Average. Okay, average. Here's my interval. So it's 1/b, which is 2e, minus a, which is e, times the integration from b, which is 2e, to a, which is e, of 1/x. Do not forget the dummy variable, dx. Now, this is not a power rule. This is a point-blank derivative rule, meaning the derivative of something is going to end up being 1/x. Okay? This is like memorizing trig rules for derivatives. This is memorizing natural log. The derivative of the natural log of x is 1/x. If this is the derivative this way, I'll do, I don't know, dang it, f prime. If that's the derivative, then this is the integration. The integration of 1/x is ln of x. So this right here is the ln of x, but I want that from 2e to e, buddy. Okay? Let us not forget, I need to find this whole thing and multiply it times 1/2e minus 1e is just 1e. All right, simple enough. Now, when you think to yourself, wow, this isn't bad, there are a lot of rules with simplification when I have Euclid's number e and natural log. But first, let's just, move forward. I'm going to put 2e into my ln function first, find out that value, and subtract, putting e in there next. So I have 1/e times the ln of 2e goes in there first, minus the ln of e goes in there next. The ln of e is equal to 1. Okay? And I will just leave this the ln of 2e. This can actually be simplified more, but I'm going to leave it for right now. This thing times 1/e. If they wanted the integration, that's fine the way it is. If they want us to simplify, okay, we can take this another step forward over 1. It's the ln of 2e minus 1 all over e. That is good, but if they try and simplify, or if this is multiple choice and they have something that doesn't look like this, that's because there is a rule here. There is a rule, bang, right here, okay? The ln of 2 times e is the same thing as the ln of 2 plus the ln of e. And then I still have my minus 1/e. Okay, we just said the ln of e is the same thing as 1. And what's 1 minus 1? Well, they cancel. So I can technically get the ln of 2/e. This is what an answer could look like. You could have come up with this, which I had in green, and not see it because it might have looked like this. Because you got to know your rules, your product rules, your sum rules, your quotient rules or division rules for logs and natural logs. Those properties are important to know because they occasionally come into play. So the ln of 2/e is a superb answer. But, I mean, along the way, if you would have come up with this, that's technically equivalent. If they don't ask you to simplify, you don't have to. You come up with this, that's good. But if it's multiple choice and you don't see it written there, I bet you dollars to donuts. And trust me, I like dollars and I like donuts. Okay? I'm guaranteeing you it's probably going to be ln of 2 over e. Oh, my good friend, U substitution. This comes into play so much with integration, it's crazy. All right? Not always, but frequently enough. All right? Now, how do we do this? This is just a quick little rundown. And of course, it's always easier to actually do the math than to see the algorithm or steps on how to do the math. Okay? So U sub integration. First step, part one, I'm going to set my appropriate expression equal to U within my integration, okay? After I have what U is equivalent to, I'm going to find the derivative of U, whatever expression that is. And I'm going to solve it for dx or for whatever I need to substitute in for, okay? Then I'm going to actually go ahead and substitute in both U and du into the integral, and I'm going to evaluate that integral with U, not with x anymore. At the end, one of two things are going to happen. I need to put my original expression back in for U that I substituted out for in the beginning. But if I have upper and lower bounds, okay, this is if I have no bounds. Okay, that's what I do here. And don't forget, if there's no bounds, I always got to put a plus c, right? In any integration I do. But if I do have bounds, I'm going to do this U shortcut kind of thing. And that will make it, I think that's easier than doing it without the bounds. Okay, when dealing with U sub, I think bounds are easier without the bounds. Anyways, let's go ahead and do this stuff, and let's see what happens. There we go. The integration of x plus 4 to the power of 5 dx. Let's take a look at this first one. First one first, there are no bounds. I know I'm going to have a plus c at the end, right? I'm going to have to do a plus c at the end here. All right, so here's what I need to do. First of all, that's difficult to integrate. I could, if I wanted to, have x plus 4 times x plus 4 times x plus 4, and I could do that 5 times and FOIL them all. Okay, 5. Hey, Allie Sharp, that's 2 in a row. She is now available. Wow, that's weird. Should we go ahead and send her a message right now? Nah. Let's let her be. Let's not bother her. Anyways, x plus 4. And I could FOIL that out and end up with some x to the 5th plus something x to the 4th. And I could integrate term by term. I could do that. If you know Pascal's triangle, maybe that's the easy way to do this. But I'm going to use U sub here. Meaning, x plus 4 to the power of 5 might be difficult to integrate. But what if I said I want U, and I should write this first. If I made U x plus 4. So now I'm going to integrate, instead of x plus 4 to the 5th, it's U to the power of 5, okay? Now, according to my steps, once I have U, I need to find out what du is. In order to take the derivative of the right side here, it's just 1 dx. That's it. Okay? So here's what's going to happen. I'm going to take U, and anywhere there's an x plus 4, I'm going to put a U in. Right there. And now, since du equals dx, any place there's a dx, I'm going to put a du right there. That is a million times easier to integrate. I just use the power rule. Okay? So I take my u, and first I add 1. 5 plus 1, this turns into a 6. And then I divide by that number. That's integrated. Now, because there are no bounds, I always need to do plus c. All right? However, when I'm looking at my original equation, or integral, this is in terms of x, right? So my answer, it's not just going to be a number. I need to have an expression in there with an x. So wherever I have a u, I need to substitute my x plus 4 back in for that u. All right? So x plus 4 in for my u to the power of 6 divided by 6 plus c. That is a fantastic answer. You're good. You're good at what you do. All right? No, you're good, Mr. Visca. Well, I know I'm the teacher. I'm supposed to be good at this, but you're following. All right. So that was a problem without bounds. Let's introduce a problem with bounds. Okay. Enter the integral of 9 plus x squared dx from 3 to 1. All right. Now, again, we'll do this in green. I've got to find a substitution for u to make this easy. I'm going to make u equal 9 plus x. All right. So I'm going to say u equals 9 plus x. So the derivative of that is just 1 dx. Okay, we're good. Okay, but now I have bounds. These bounds are currently in terms of x. When x equals 3, x equals 1. I am going to convert those into u bounds, meaning when x equals 3, I'm going to use this, and I got 9 plus 3, so my upper bound, when x is 3, my u is going to be 12 for my upper bound. And for my lower bound, when x is 1, well, I've got 9 plus x. Okay, so it's 9 plus 1. That's 10. So my new upper bound and my lower bound in terms of u are 12 to 10. So let's substitute everything I have in here. I integrate from 10 to 12 now, because these are now u equals, right? I am going to substitute in for this, my u. That goes right here, all right? And then in for dx, I'm going to put du right here, all right? Let's go ahead and do this. U squared, and instead of dx, du, all right? But I have my u bounds. And I'm going to explain to you why I changed these u's right now. There are actually two reasons, okay? Let's integrate this. I add 1 to my exponent, and I divide by that. And I want that from 12 to 10. All right? Now, I don't have to bring my x back in here. I don't have to put 9 plus x here and then go back, and I got to look at my bound and put in a 3 and a 1. Why do that? I'm just going to leave it a u, because these are in terms of u now. So I'm going to put in a 12 in for my u, cube that over 3, minus putting a 10 in for my u, cubed over 3. So I end up with 12 cubed minus 10 cubed over 3. I don't expect you to do that in your brainsies. So what I'll do is I'll do that right now. Oh my goodness, jump. We got a jumper. We got a jumper. 12 cubed minus 10 cubed. That's 728. If I divide it by 3, does it go unevenly? No, it does not. So I'll call that 728 over 3. There you go. Now, I told you I was going to tell you 2 reasons why I substituted in these u's right here. Number 1 is, well, look, this was so much cleaner putting these numbers just in for this variable than putting in a 9 plus x back here. That it's easier. That's the first reason. The second reason is multiple choice questions on the AP exam. They will ask you, they will say, okay, they give you this and say, if I was to do u sub, and if I were to use 9 plus x for my u, they will tell you this. Which one of the following would be the appropriate integral set up? And the answers will look like this. Okay? One of the answers will keep a 3 into 1 here. Okay? One of the answers would be the integral from 3 to 1 of u squared du. That is incorrect, because according to u substitution, this 3 will turn into a 12, and this 1 will turn into a 10. This is the correct answer. And a lot of people circle the bounds with 3 and 1, but that is incorrect. So you should get in the habit of making that u substitution on your bounds right from the get-go, just like we did. All right? Oh, my God. Oh, God. Help us all. Now, let's do this last one. Let me make some room here. I'll do this in red, and we'll move forward. Oh, man, look at that. LA Sharp is, again, available. Weird. All right. So, here's what's going to happen. U sub. I'm going to make U equal to this right here. And you might say to yourself, Visca, there is no way on God's green earth I would ever have picked that as U. I'm going to explain to you why you should know. What happens when I take the derivative of U? Okay, the whole key to picking U is when you pick U, the derivative should also be in your integral. So, for example, highlight purple. Well, that if I make U x plus 4, the derivative of U, dx, is also here. Okay? If I make U 9 plus x, the derivative of 9 plus x, dx, is also here. If I make U 2x squared plus 1, the derivative is also there. What do you mean, Visca? The derivative of 2x squared is 4x, and then I also got to have my dx here. So the derivative is also here. That's what you want to happen when you pick a U, that your du is also in front of your face. So let's substitute these in. There are no bounds, so I know I'm going to have, a plus c at the end. Okay, I'm not going to have to do U sub. I'm actually going to have to bring in my x expression back in. All right, so let's just rewrite this with this little tidbit we have right here. Okay, the integration. I have a fraction, radical U, because 2x squared plus 1 is turning into U. Now, substituting in for 4x dx, I'm putting du in for all of this. Just put a du right here, and this will just stay a 1, because when there's nothing on top, we leave it a 1. You see how the 4x goes bye-bye with a dx for du? That's why whatever this is here, always make sure you can take the derivative of it, okay? And it goes bye-bye. Now, let's clean up my integral so that I can integrate it easier. Okay, that's the same thing as saying the integration of 1 over u to the 1/2 du. But I'm going to pop this up and call it the integration of u to the negative 1/2 du. Okay, that du is not in the exponent. I don't know why I was floating it up high there. Du. So my power rules still apply. Okay, I need to add 1 to this exponent. So it's u negative 1/2 plus 1 is positive 1/2. And then I got to divide by that. Dividing by a fraction is the same thing as multiplying by its reciprocal. Don't forget, I still need plus c. That's done. You have one last step to do. Whatever I took out in place of u needs to go back in. Oh my goodness, everything's weird. Here, this needs to go back in for my u, 2x squared plus 1. So, u, 2, u, it's 2x squared plus 1, to the 1/2 plus c. Now, that's an appropriate answer. If this is multiple choice, maybe they make the 1/2 back into a radical, because that's where it started. You might see this. Either one of those answers are beautiful. Beautiful in their entirety. And that, my friends, is a great place to stop. Part 1 video was like 31, 32 minutes. We were a couple minutes over. I'm going to make part 2 a couple minutes under. Sorry, I just like touching the board and scrolling. It's so fun. So, ring the bell, like the thing, make the comments. We're all cool. I'm hip. I'm cool. I know you want to be me, but there's only one me. And guess what? It's me. I'll see you for part 3 next. Hey, be quiet. Yeah, see that? That's what we call a jerk in the industry right there. I'm going to give you his initials, CM. Y'all can guess who it is. Okay, no, I'm just finishing up a video. We're good. See you later. Have good. See you part 3.